this lecture, we will talk about working with classes and instances. So let's write a new class representing a car. Our class will store information about the kind of car we are working with, and it will have a method that summarizes this information. So we defined an initial method first with the self parameter first. We also give three other parameters: make, model, and year. A method called getDescriptiveName that puts a car's year, make, and model into one string neatly describing the car. Then we make an instance from the car class and store it in the variable myNewCar. Then we call getDescriptiveName to show what kind of car we have. So this is the class called car. This is the class, and inside the class there's two functions. The first is the initial function, diff_initial, with the self first. Then three parameters called make, model, and year. This will get the information when users create an instance of a car. So inside the initial function, we assign these three values, make, model, year, to three attributes called make, model, year. So the right side actually are values inputted by the user when creating an instance of a car class. Then the left side, three with the same name, are attributes of this object, this instance of car. And the second method called getDescriptiveName, self representing this car. Inside the function will be a variable called a long name created with the concatenation of year, make, and model. Then we return information, return this variable's title form. Then after we have created this class called car, we can make an instance of car. So this is an object called myNewCar created, and the right side is we make instance. So car is a class. Then in the parentheses we input three values for make, model, and year. Then we can print the information using the getDescriptiveName method after the dot of this object. And for the class, we can set a default value for an attribute. So every attribute in a class needs an initial value, even if that value is 0 or an empty string. In some cases, such as when setting a default value, if you do this for an attribute, you don't have to include a parameter for that attribute. Let's add an attribute called odometer reading that always starts with a value of 0. So we change this initial function in the class, and we add an extra statement called self.odometer reading is 0. So inside for the user input information, do not need this odometer reading now, because in the initial function we have assigned a default value to this attribute. That means the car has an attribute called odometer reading with an initial value 0. Then we will also add a method readOdometer that help us read each car's odometer. So inside the class we define an extra function called readOdometer. So this function's job is to print the car has how many odometer miles on it. So this statement string self.odometer reading actually get the value of the attribute of odometer reading of this car, self-represented this car. And we can use this method after we have created myNewCar, this object now. So So we can use dot read odometer can get how many, then we print this information. And modify attribute values. You can change an attribute value in 3 ways. You can change the value directly through an instance, set the value through a message, or increment the value, add a certain amount to it through a message. So first, modifying an attribute value directly. The simplest way to modify the value of an attribute is to access the attribute directly through the dot notation of an instance. Here we set the odometer reading to 23. So we can, this is outside of the class. Actually, we have created an instance of car called my new car. So we can use dot notation, dot odometer reading, and assign a value to this attribute. Then we can use a read method, read odometer method to read this new value. And we can also modify an attribute value through a method. So instead of accessing the attribute directly, you can pass a new value to a method that handles the update internally. Here is an example showing a method called update odometer. So we write a new function into class car called this function called update odometer, and there are 2 parameters. First, self is always need this self because you want the car can use this function, so you have to add a self in it. And the mouse is a new parameter, actually is user input when calling this method. And inside this function, the statement will assign this new value to the attribute of odometer reading of this car. So for example, outside of the class, we can make an instance called my used car. Car is a class, then inside this parentheses we add 3 information, make, model, year to this car object. Then we can update this car's odometer to 23,500 miles. Then we can read again. Actually, now the read odometer will get 23,500 miles now, not 0, because it has been updated. And we can extend the method update odometer a little bit to the additional every time odometer reading is modified. Let's add a little logic to make sure no one tries to roll back the odometer reading. So inside the class, we modify this function called update odometer self miles. So we use an if statement for the conditional test. So if the user assigned this miles is larger than the current value of odometer reading, then we will assign this miles to this attribute called odometer reading. Else, so if user input a miles value is lower than this current value of odometer reading, then we will print a message, you cannot roll back an odometer, and we will not assign this new value to the attribute odometer reading. And the third way of change value of attribute is incrementing an attribute value through a method. So sometimes you will want to increment and attribute value by a certain amount rather than setting an entirely new value. Say we buy a used car and put 100 miles on it between the time we buy it and the time we register it. So here is a method that allows us to pass this increment amount and add that value to the odometer reading. So we next add an fourth function in the class called increment odometer self miles. And inside this function, there are statements actually is add miles to this, add increment miles to this attribute odometer reading. So it actually is equals odometer reading equals odometer reading plus miles. So this miles is the increment information user want to input when use this instance after have been created. So outside of the class, we can make an instance now called my used car is Subaru Outbreak 2013. Then we can increment odometer reading with 100 miles. Then we can read again. So we will show these commands in Anaconda Spider now. So we move to the file called section 8 classes py. The files link has been added in the description of this video. And we move to lecture 2, working with classes and instances. So first we'll create a class called car representing a typical car category, and inside the car their first initial function will take in 3 parameter arguments from the user when creating this instance, and we assign these 3 values to 3 attributes called make, model, and year. Then the default value 0 will assign to a false attribute called odometer reading, and this attribute need not information now when user creates this object now, because it has an default value. Then there are actually four functions are written to get a descriptive name, get a name of this car, and read odometer. You will read the information of how many odometer miles of this car, and update odometer. You will update the odometer reading, this attribute, with a new value. But here is the if test, so the new value cannot be lower than the current value. And this function is increment odometer will add and will increase odometer reading, this attribute, with a value called miles. But we can change any parameter in a function. If you, for example, here change it to millage, you must write millage here. So this is because the function parameter only, local scope only used for inside this particular function, and this miles also only used for in this particular function. So this is not the same thing, not the same variable. This only for local scope inside of this function. So outside of this particular function cannot know this value. Same for this one. So now we can create object of car, create instance of car, use car Audi A4 2016. First we have to create this class first. We have to run this whole class to run. So this class has been created in Python. Then we can make instance of a car called my new car. Run. So my new car is created. Now we can print my new car's name information. A method use dot notation after my new car. So this information printed out. We can get odometer information similarly to use dot notation, dot also a method, actually the function inside the class. Then so this car has 0 miles on it because the default value is 0. And now we can modify an attribute value. My new car, so we assign a new value 23,500 miles to this attribute. Run this, then we can read again. Now this car has these miles on it, and we can modify an attribute value to a method. So my new car, we create again my new car called Subaru, and we print out the car's information. Subaru 2013 Outback model. Then we update, use update method, dot update meter with a new value. Then we read again. So this car has 23,500 miles now. Now we try to use a lower value than the current value for the updated odometer method. We learn this. You cannot roll back an odometer. So this is correct. And the last method is incrementing an attribute value through a method. So we can create again by use the car, then print the information of this name, Subaru 2013. Then we read odometer now. Now it's currently 0 miles have been used, and we update with a 23,500. Then we read again. Then we use dot increment odometer with 100 miles increment for this car. Then we read again. So now this car has 23,600 miles on it.